Have you ever wanted to make a real industrial robot perform a pick and place task completely in simulation using Gazebo, MoveIt, and a robotic gripper before to go in real life? Today I'll show you exactly how to do it step by step. Hey roboticist, I'm Francesco, a robotics software engineer, and I'm specialized in industrial automation with integrated vision system. On this channel, Learn Robotics with ROS, I share what I've learned from real industrial project, from robot programming to simulation and computer vision, all using ROS, ROS2, and MoveIt. And we will tackle in the next video Isaac Sim and Isaac Lab for training. Okay, so my goal is help you to level up your career in robotics by teaching you how to solve a real automation task in a simple and intuitive way so you can apply these skills in your own project. So I'm gonna give you the tools you will need in order to design and develop your own application with your specific needs. Okay, so if you're enjoying this kind of content and you wanted to grow in robotics engineer, subscribe to the channel, hit the notification bell, and there's a lot more coming. Okay, so now let's get started. So in the last video, we have seen how to use a collision object and use Octomap. There are in both scenario some pro and cons, so feel free to use the one that you want. So now the object of this video is to pick this object and place into the bin. Okay, a very classic pick and place application. Okay, and I'm gonna tell you the pipeline that you will need to do in order to perform this specific task. Okay, so again, I have already done a video on how to simulate this environment with the controller of a Universal Robot 5, with the robotic gripper, with the camera and the word. There's gonna be a playlist, and I'm gonna put the link in the top right corner of this video. Okay, so now let's focus on the task of our pick and place. Okay, so the first thing that we need to do is to pick this object, and this object is gonna called in Gazebo cube underscore pick, and this is the model, and then the link is link underscore one. Okay, so just remember this because we are gonna see in a while. Okay, so what we need to do is to move the end effector of the robot in such a way that is going to approach this the object, the pick position, and we can say it that is going to be our first waypoint. Okay, then after that we have reached that one, we will check what is going to be the position and orientation of the end effector with respect of the base link. Okay, this is the first milestone, and let's do that. So of course, I'm gonna use the help of Universal Robot 5, or better the MoveIt, and so I'm gonna go to Home first. Okay, then let's me open the gripper. There we go. Now I switch the planning group to Universal Robot 5 manipulation, and then we try to bring the end effector in the position where we want the robot to pick. Okay, so let's play with the MoveIt, and let's see what will be the value of position and orientation of the end effector. Okay, so let's say that we have in the position of picking. We cannot go further because we have launched this spawn launch file with the Octomap. And you can see here that the Octomap that the camera is streaming at this moment is going to course the real collision object. But don't worry about that. I have teach you how to avoid this problem and hard-coded the object collision object. I'm gonna put the link in the top right corner with the related video. Okay, so now let's say that we wanted to know what is gonna be this waypoint, or better, what is gonna be the position orientation of the end effector that we can consider to be the wrist free link, which is going to be this one, okay, with respect of the base link. Let's open another terminal, and then what you will need to type is the usage of the transform 2, okay? Then we want the base link with respect of the wrist free link. Okay, how I know that? Well, you can go here to model, which is the cobot, and then you have all the link, base link, and then wrist free link, that is going to be this one. Okay, so now let's see what is going to be the value here. Okay, there we go. So it's static because the robot is it's on hold, let's say. And then you have the translation, which is the position in XYZ with respect of the frame base link. And this is the orientation in radians. Okay, so I will put this a little bit downwards with respect of the base link frame, because it's affecting from the Octomap. Okay, if you want to check what is going to be the frame of the this link, you can go to RVs. Then you can type add, and then go to transform. No, not robot model. I don't need it because there's already there. So remove, add, transform. There we go. So you can see here all the transform of all the link and the joint, but we are interested in the base link and in the wrist free link. There we go. So you can see here that the position and orientation of um, the wrist free link with respect of the base link is this, okay? And if we want, for example, that the end effector goes a little bit downwards with respect of the base link, we will need to set up a value on the Z position a little bit less. Okay, this is one thing. So what I will suggest you is to take this value, this one, and this one, and write it into a paper. Okay, and this is the first waypoints. Okay, then what we're gonna do is um, move the end effector in the second waypoint, which is going to be inside the bin. Okay, so let's do that. Of course, with the usage um, of MoveIt. So let's do like this, like this. Okay, now let's move this in such a way. Okay, you can see here that the robot is in orange, and if we go further, it's turn to red, and if you do like this, it's meaning that the octomap doesn't allows you to go in this direction. In fact, if I go plan and execute, it will be failed. Okay, but if I move a little bit here, let's plan and execute uh, again. Okay, is going to take into consideration the octomap. Okay. Okay, here you can see that even though the fact that the octomap is very close to the robot in the real life, well, the real collision object, which is the bin, is gonna be too far. Okay, but don't worry, we're gonna solve this in a while. Okay, then let's say that we want to go a little bit farther. Let's see. Okay, so let's say that we want to put in this position. Okay, so now what you can do here is always to do the same exercise. Okay, and then what you're gonna need is to save this second waypoint in translation, which is gonna be the position and the orientation in row pitch and yaw expressed in radiant angle. Okay, so we have reached this first milestone. So we have two waypoints, okay, one waypoint of picking and the second waypoint for placing, okay, and one waypoint is determined and is associated with a position and orientation. Okay, so now we have everything to start coding our pick and place application. And there we go. This is the pick and place application I have coded offline. So we are going to tackle this very fast. I'm gonna explain you how to use that. Don't worry, I'm gonna push this modification of the package in GitHub, and it's gonna be in the link in the description down below. Okay, if I'm gonna go very fast. Just to give you an overview, if you want to really understand line by line what I'm gonna do, I will suggest you to have a look in the masterclass. Always link in the description. Okay, so first, this is the libraries. This is the link attacher service that we have seen in a few videos ago. I'm going to put the link in the top right corner. We have used that in with the terminal, but now we code this service. We're going to use by coding. Okay, so this is the class pick and place. But if you want to give you an order, I'm going to explain you the main. Okay, here we are. There's going to be the ROS2 initialization and the startup the node. Then here we are going to instantiate a pick and place object. That is going to be an instantiation of the class that we're going to see in a while. Then here we add the collision object as we saw in the last video where we hard code the table and the wall of the bin, and then we are calling two functions, the pick, then we pause for a second, then the place, we pause, and then inside the pick there will be the close the gripper, and out and in this main I decided to put in to open the gripper, and then after the opening I detach the object. Okay, and using the link attacher service. Okay, so now let's go inside the pick and place application, where here in the private section there's gonna be the variable that we are using in the class pick and place. So it's like to have a global variable, but embedded, let's say, in the class that we have created to give more structure. Okay, so let's see the most important thing. So the pick function. Okay, so this is the pick function. Okay, it's gonna be very simple. Okay, first of all, we are going to set up the velocity and acceleration that you can set up in MoveIt, and then here set up some variable from MoveIt in order to just try to do more attempt in the picking. Okay, again here I'm letting MoveIt to do everything. So to find a solution for inverse kinematics in order to go in the target position and orientation, and at the same time avoid to make a collision with the collision object that we have are coded here. Okay, I hope that is clear. Now here we are going to instantiate a geometry message type of message that we're going to call a pick pose. Same things orientation. This is going to be in quaternions. Okay, and do you remember the data that I told you to the waypoint that I told you to save? Well, basically these are this one. Okay, they are slightly different from the previous one because I have got this data by spawning the robot without the opto map, so there was more precise. Okay, then so I have set up the position and orientation of what? Of the wrist free link with respect of the base link. And this setup, I have put it here as the constructor of this class. Okay, here I have set up the move group for the manipulator and for the gripper. Okay, basically here after that I have set up this waypoint. Okay, then I make a planning. Okay, and if the plan is going to be success, then we can just move it. Okay, and we're going to use the move function. Okay, okay, so inside the move I am calling the two function, or better two method of this class, pick a place, a close gripper and attach object. Let's go more in depth. So we're gonna have a close gripper. Well, basically we are setting up the joint position of the joint that is responsible of moving the gripper. Okay, and then I just move it. Okay, again here I don't need a planning group, a kinematic algorithm. Okay, it's just setting up a target joint angle of one particular joint. I remember you that I have coded this in such a way that it's going to be a mimic effect. Okay, and then open gripper. This we will see in a while for the placing. Okay, and then I am calling the attach object, and this is the dirty tricks that I have already explained to you by tricking the physics. So here I'm gonna set up the request of the service attach object. Okay, and here there's gonna be the model one, the robot. Okay, and this is the link belonging to the model one, and here the object to which we want to attach to. Okay, and this is going to be the cube pick and the link one. Remember that this model name and link name, you need to use the same value of that you see in Gazebo. Okay, you need to be aware of that. Okay, and here basically we are gonna set up the request, setting up these things here. And here we are going to ask the server to make his job. So this node is going to be the client, okay, of the server. And then basically this client is asking a request to the server and is going to respond with if it's going to be success or not success, okay? And if it's going to be success, I'm going to display on the terminal this. Okay, so this was the peak. Okay, if we follow the logic of the this main, we're gonna go in the place. So the place function is very similar to the peak. Okay, with the waypoint that we have set up it before, and then the main function is asking the detach. So basically, it's going to be the same function of attach object, but this time asking a request to the service detach link. Okay, and here there's going to be this function, or better, a method of the class pick and place where we code with hard code the collision object, as we saw in the last video, with the position and the orientation and all the dimension that we have set up in the previous video. Okay, here I have not put the the object because otherwise I had to code the attach collision object, but this is a more complex topic that I'm not covering in YouTube, okay, only in the masterclass. And then basically that's it. Okay, so basically after that remember to create after that you have coded it, you remember to create a an executable. Then let's test it. And let's launch our launch file, but with Octomap false. Okay, we have everything to test it. I hope that you are as excited as me. Okay, so let's ROS2 run the name of the package. Okay, and then pick and place. Let's run it. You can see here the collision object. We are gonna go in the picking position. Okay, we close the gripper, we trick the physics, okay, with the attach collision object, and we go in the pick, we release, and we detach the object. Okay, so basically that's it. Okay, and remember that the waypoints and the trajectory of the the robot take into consideration the collision object that we have hard-coded, okay, making the right pathway. Okay, so that was all for today. I hope that you enjoyed this video. Now you know how to run a pick and place application. Of course, using the link attacher is not gonna be perfect, but it is gonna be a good start and gives you a good pipeline to start to see if your robot is capable and is gonna be in the cycle time to perform a certain task like bin picking, and then you have everything that you need to simulate your industrial environment using a collision object. So you can see what is going to be the real pathway that your robot needs to do in order to perform their task, but at the same time avoid any collision object. Okay, and this was only the tip of the iceberg, and if you really wanted to deep dive and understand in a real depth what I've done and how to code it, and of course run a more complex application, feel free to have a check to this master class that is specifically designed for learning ROS2 MoveIt simulation environment with the computer vision integrated. And this is designed to be from zero to an expert only in simulation for the moment. Okay, there's gonna be the curriculum here, so feel free to check it. And every month I'm gonna create a new module. Okay, so I'm gonna put the link in description down below. And again, thanks for your attention. And as always, keep learning robotics with Ross.